So we are still in the closed molding system, okay, and in this case we are talking about the resin transfer molding. So what is it all about? Let's take a look in this video.
SLRI, designed for resin transfer molding, using the most varied resins with 1 or 2 components, injected at 6 bar, 90 psi, and cured at 180 degrees Celsius.
So take note that the red color one is the resin, the blue is the catalyst. So it is perhaps to actually speed up the curing process, so you can make things more faster. Production time will be lesser, things like that. Alright, and this is how you create a resin transfer molding. So you transfer the resin to the molding. This is just the meaning of that. In other words, this is the resin. So you transfer the resin using pressure into the mold. This is the mold, and this is why it's called the resin transfer molding, and therefore it's easier for you to memorize. For now, I'll just speed it up a little so at least you can see the full scale thing. Alright.
Reinforcing fabrics are placed into the mold cavity. In the second step, a precisely shaped SLRI core is inserted and covered with reinforcing fabric. After this brief preliminary work, the injection process is prepared. That includes closing the mold. The required tightness of the mold is ensured by means of screw unions provided around its circumference. Finally, the connections for resin injection and heat supply are attached, and sensors are positioned to control the mold temperature. With its excellent mechanical and thermomechanical properties, SLRI can be processed with all commercially available resins at extreme pressures of up to 6 bar or 90 psi. The injected resin impregnates the fabrics and adheres them to the core. SLRI is designed for high-performance injection processes. Curing temperatures up to 180 degrees Celsius, 356 degrees Fahrenheit, and post-curing temperatures of up to 250 degrees Celsius, 446 degrees Fahrenheit can be applied. The setup and implementation of the process ensure.
So therefore, as you can see, it's a very labor-intensive method, because it takes a lot of time to actually remove all the parts. Alright. This method requires you to draw in the exams, may require to draw. So therefore, you may need to understand what are the stuff. Alright. So what are all these arrows? Alright, is that these are the parts, I think, the molding parts. Alright, while the 5 and the 6 are just your materials. I don't think you need to memorize the numbers, but you just need to identify that this is a catalyst, this is a resin. Alright, and then you fed it with a pressurized system, okay, and then these are the molds lah. So over here, once you do that, and then all it is, yeah. But anyway, there are variations to this which lead to more accurate moldings, alright, and less material wastage, because the variations, talking about the shape of the variation, you can design the different tool that you want. Alright, so therefore different tool will give you different shapes. Alright, but the problem is that it requires a lot of it's kind of labor intensive. Alright, I believe all these little dots over here are your fibers. Dry reinforcement is placed between two match mold. So therefore I would assume that the molds, all these little dots are the fibers. So if you were to go 3D, alright, so these are all the fibers placed like that, and then after that you feed it in. So at the end of the day, you will get to see something like that. Alright, this is the shape. So these are the fibers that you can see. So the fibers are kept in between your molds. So these are the resins. Alright, this shaded one are the resins that you fed it in after you fully cure it. Alright, and therefore this is the method for the resin transfer molding, where you transfer the resin to the molding. And therefore next up is the over here RTM finish. So we will talk about the vacuum bag molding. Now I'll explain what is vacuum bagging, or we call it the autoclave. Alright, let's take a look for a larger scale system. I don't know what he's doing, but yeah. So I think he's trying to put in all the materials inside the thing. So over here they are actually linking the pipes into the materials or the bag. Alright, so each of them is the bag that you are looking now. Okay, so yeah, so they put in the valve to the bag so that they can fill in the resins. So just hold a while. Yeah, so therefore as you can see, these are the bags. Alright, these are the bags. Alright, and as you can see, there is a certain valve over here. So this valve will connected to the pipes. This all the pipings will all the way go out to the machines. As you can see, it's all on top of here. Then over here the machines will actually fit in all the resins, alright, into the thing. So the resin will go through all this thing and fit inside the bag, and therefore this is the bag, the vacuum bag, because it's fitted in within the vacuum itself. So once you close the lid, alright, once you close the whole machine, alright, this is the machine. So this whole thing is the machine. So when you close this whole machine, alright, then you'll create a vacuum, alright, and then after that you'll fill in the resin and you'll cure inside with certain pressure and heat, alright, and therefore you can just continue to watch. Yeah, so this is the end product, alright. And to be more specific, alright, inside this piece is a certain covering, alright, where I would think that inside here these are the materials, I think only lah, okay, but at least you get to see that you can manufacture a lot of material, so you can have 3 of them all together. Alright, you put inside the shelf and then you vacuum back. Alright, so therefore in other words, the vacuum bag process is that you put it inside a vacuum. Alright, you put the resin inside a bag that is vacuumed. Alright, that is vacuum. Why is it vacuum? Is because it creates no air. No air meaning that it will not be because air gaps actually could cause your material to fail quite easier. Alright, yeah lor. So therefore you want to reduce the air gap, and therefore this is why you want a vacuum. Alright, and therefore vacuum airbag itself. So over here I think you can read it yourself. The only thing is that it's usually used with a pre-prep resin system. Alright, so if you can just head back to the first PPT slides, alright, page 102, or you get to see the pre-prep, or in the future we'll talk about pre-prep also. Alright, where this method itself, alright, is being pre together with the thermoset resin. Alright, so by itself, if you remember, this is for pre-prep is talking about thermoset resin. So the thermoset resin is being placed inside it's being placed together with the fibers, alright, but haven't cured yet. Alright, when you want to use, then you cure it, alright, for good purposes lah, for strength or other purposes. But in other words, normally the pre-prep is actually using or the pre-prep is actually manufactured using vacuum bag or autoclave, and there is a way to actually explain what is vacuum bag autoclave. Is that for pressure that is higher than 1 atmospheric pressure, alright, then you use autoclave or heated pressure vessel, or in other words the one that you have just seen just now in the video. Alright, the very big this very big thing is considered a vessel. This or autoclave machine. So if you require a certain 1 atm pressure or above 1 atmospheric pressure, you require autoclave machine. Alright, lower than that you can just use a bagging bag. Alright, a very simple tool. Alright, and I think let's just take a look on this vacuum bagging process. Alright, because the autoclave one you have just seen that video. For the vacuum bag, alright, you can actually see this, and the purpose of why watching this is that you'll better understand this manufacturing process if you were to ask to draw also. Alright,
Hi, this is Randy Zajac, Technical Advisor at Goujon Brothers Incorporated. Today we're going to take a brief look at the vacuum bag process while laying up a fiberglass canoe hull. Before we get started, here's a quick look at the elements used in this particular layout. Mold release, gel coat, fiberglass, peel ply, breather fabric, vacuum bag sealant, and vacuum bag film.
So the mold release is the one that, if you remember, is to allow easier removal of the material after you have fully cured it, or if the material is finally heated. Alright. Or in other words, I repeat again, the mold release over here at the very first layer is to allow the material to be extracted easily, alright, without sticking onto the surface of the mold. Okay. Then the gel coat will allow the fiberglass to stick onto it. Alright, where the gel coat itself also is to protect the fiberglass. Alright, and then peel ply is the different plies you laid up together, and breather fabric later on I think he will talk about it, so the rest you just watch now.
To wet out the fiberglass, we used West System 105 resin mixed with 206 hardener. The gel coat was a mixture of West System 105 resin and 205 hardener thickened with 406 filler. Here we are cutting our vacuum bag film to length. Ideally, the film is about 20% larger than the mold to allow enough room for contours without bridging. To start, we found the center of the film and stuck it down to the center of the mold with the vacuum sealant tape. We worked the film from the center out, making pleats in the bag every few inches. The number and size of pleats is determined by the complexity of the parts.
And the tape is very expensive. So what they are doing now is actually to do out the back, alright, as you can see. So they place the valve inside the bag. So this is after they actually fit in the resin. So previously this is the bag. Alright, I think I'm lagging already. And continue watch here because just now there's no sound.
Once the bag is completely sealed to the mold, we mark the position for the vacuum cup and cut a piece of the film away for air to travel through. We put vacuum sealant tape on the suction cup so it will stay sealed if vacuum is lost for a short time. Suction cup placement depends on part geometry. Typically you don't want to put it on what will become the finished part, but off to the side. It was not an issue for our canoe here. A trap is put in line with the vacuum tubing to catch any excess resin before it goes into the pump. The air is evacuated from under the bag and a vacuum is generated. As the bag is evacuated, it is important to position it to avoid bridging in any tighter spots. If you have any leaks, fix them with vacuum sealant tape. Once the part is under vacuum, don't remove the bag until the part cures. After the part is cured, remove the vacuum bag, breather fabric, and peel ply and pull it from the mold.
And this is it for the vacuum bagging. Okay, and over here there will be this suction cup.
Stay sealed if vacuum is lost for a short time.
So this suction cup is not a feeding of the resin. This suction cup is to suck out all the air. Alright, and be careful of that thing. And therefore, if you were to come to here, there is certain things like release film. This release film is, in other words, to help you to extract the material easily, so that it will not stick onto the mold. Okay, and there was a pre-preg layout. So over here, I don't know what the hell is going on. The resin dam. So I would think that is where you fit in the materials from the some outside thing. So you'll be connected. If you were to go 3D now, alright, you'll be connected outside to certain pipes. Alright, so this pipe will be underneath this vacuum bag film. The vacuum bag film itself is to prevent any air from flowing out or in. So it will create a vacuum. Alright. Then the breather fabric itself is to allow the material to within the material to actually because once you fill in the resin and the fabric itself, alright, there will be certain air also, certain air generated. So the breather fabric itself is to allow the air to actually exit the bag, so that once it exit and being sucked up from the sucker, alright, the suction, air suction, alright, and then it will be removed from the whole vacuum bag. I know my explanation sucks, but anyway, so this is it lah. And just need to know that this labor intensive, alright, and also requires the skill of the labor, and it takes time. It's a time it's not a very good time efficiency material. I mean method, but rather than is pretty it consumes a lot of time, okay, for vacuum bag. Alright, so for autoclave, I think the machine itself is pretty easy. For vacuum bag, then you use the method that I've just shown you, so you can just memorize it. And if you still don't understand what is vacuum bagging, alright, you can just watch this video. Otherwise, you can just go on to the next one, alright, because I don't want to drag the time, because I also think that my explanation sucks. But anyway, this is it for the close molding. Alright, and in the next video we'll continue to talk about other stuff that is not discussed in the slides, but I think I'll just talk it out in terms of for future usage lah. Alright, and in fact I didn't actually talk about the dry or prep laminating, so therefore in the next video I'll also talk about that also, because I don't know where does this thing comes from and how does it link to the one over here, this summary. So I would think it's continuous lamination, but anyway, you can just leave the video now, and if you want to watch, you can just watch this one for better understanding of the vacuum injection molding. Alright.
The basic principle of vacuum injection is to inject resin through dry reinforcement placed between a rigid airtight mold and a flexible film. Vacuum injection can offer distinct advantages to molders. There is minimal capital investment. Existing molds from hand or spray layout can be used. It is adaptable to a range of components of different sizes. Physical properties are improved due to the compression effect from the vacuum. Changes in component design can be incorporated easily. Reinforcement is loaded onto a gel-coated mold. The mold can be a modified layout mold. Core materials can be easily accommodated, but the molder should ensure that resin can flow around them and that care is taken over their accuracy and placement in the mold. A galvanized metal coil can be used to create a peripheral channel. If a new mold is made, then this channel can be built into the mold flange. Plastic T-pieces are used to allow easy tube connection. Vacuum bagging tape is placed around the mold. The flange should be free of glass fibers, which may create a leak through the tape. Plastic mesh can be used to aid resin take-up at the end of injection, or be used as a gate to distribute the resin quicker across the mold surface. Use of peel ply allows easy removal of this mesh after demolding. The key to vacuum injection is a textured film which allows excellent resin distribution with no additional layers over the laminate. The molder should ensure that there is enough film to take the shape of the molding. Up to 50% more film than molding area may be required. The film is sealed carefully using the tape. Pleats are used to ensure that there is no bridging of the film. A vacuum is applied and the film checked for leaks. Finally, the film is slit and a tube attached in the center. Resin is fed from the outside tube into the peripheral channel with a vacuum of between 0.6 and 0.8 bar being pulled from the central point. This method has the advantage of quicker fill times, but the disadvantage of a greater risk of drawing air across the laminate if the bag is not sealed properly. An alternative is to feed the resin via the central hose connection and pull the vacuum from the outer channel. When full, the resin inlet is clamped. Some resin is pulled into the outlet catchpot to ensure a full air-free component. This outlet can then either be clamped or the vacuum slowly reduced to a holding level of approximately 0.3 bar. The mold must be held under vacuum until the resin has gelled. Once sufficient cure is attained, the mold is stripped. The part is demolded and then trimmed. There is a loss of laminate thickness.